Here in the Valeo R&D Center in Prague, one of our main goals is to develop ADAS functions, and what it does means. Well, ADAS stands for Advanced Driver Assistance System, and the goal is to support the driver to have a comfortable and a safer trip. We're gonna cover the full path of ADAS, starting from the sensors. In Valeo, we deploy a diverse gamma of sensors, for example, cameras, radars, lidars. And these sensors are known as perception sensors because they will perceive the environment around it, and we're gonna use the data from the sensor to perform the perception. And the perception is a crucial point because we're gonna translate this data into meaningful information. So we're gonna get the states of the other vehicles in the scene, for example, position, velocity, and we're gonna also get other features as the traffic lights and other complex infrastructures. We're gonna use this information to start to build what we call end-user functions. Therefore, we are speaking about a huge and a complex system, and the system engineer is a key player here. We're gonna follow the full cycle of the project, and we need to communicate with the different players. Therefore, we are following the project from the very beginning to the very end.
Here in Valeo, system engineering is also about reusing pre-developed parts like sensors and functions and adapt them to customer needs, develop for them some activation logic, enable diagnostics and much more. Since the beginning, we are part of proof of concepts development to show to our customer that our system will be working in their vehicle. By vehicle, I mean passenger cars, but it can be also a Tatra truck, for example, as Valeo has recently entered the segment of commercial vehicles. We are since the beginning in a close touch with the customer, daily interacting with him, discussing customer requirements and clarifying technical needs. For this, understanding our sensors and functions is essential. We are also responsible to develop the internal system specification and ensure that every part and sensor and function we have included in the system is matching the customer wishes. At the end, close to the delivery of our system to our clients, we're responsible to take care about problems and bugs. We use both virtual simulation as well as a real-world environment to debug and tune our systems. It can be very challenging to deal with real-world physical constraints. For example, deal with residual water film behind the wiper when tuning a rain light sensor. In one sentence, we're developing high-tech features to make our customers happy.